Welcome back everyone. Today we will continue on and dig in a little more in detail about exponent function and logarithmic function. So let's take a look here. Before we start, we will just write down some basic properties that we know pretty well by now, but we will just remind ourselves. When it comes to exponents, we will have anything with power a and b, you can add them. And anything that you're dividing by, you could subtract them. And when you're doing exponent to that, we are going to multiply that. Okay, that's something you should remember. And of course, one more thing is that when I have minus power, it's same as writing this thing on the bottom. All right, let's write down one more stuff for logarithm. Okay, logarithm, the way I studied last time is that anything a to b power is equal to c, that's same as writing logarithm of a to c is equal to b. So it's just really inverse function to each other. So when it comes to logarithm, you have to be careful. We will have something like a and b. If I add them here together, then it means you can do multiplication and then do them together. And of course, subtraction would be the other way. AB minus logarithm of AC would be logarithm of B over C. Couple more things. If I have logarithm of A to B to some other power, I can always take the K out to the front and then make it this way. All right, anything else do we need to see? Over here, we could do logarithm of same number is 1. That's always true. Okay, and one more thing that we could do, it doesn't show up very often, but if I have something like a to b, I could always change this to some other logarithm with base, some c with b over c with a. So that's true as well. And one more thing is logarithm b to 1, any number here, 1 is going to give you 0. Okay, so let's use those properties to do some simple questions here. Let me just keep them over here and then we'll work on it on the left side. All right, starting with some exponent examples. Let's say we have x to the power, let me use the example 1 there. X to power n minus 1 power, x to 2n power, plus we could change this form a little more, 3 plus n to the power of 3. Then put them together. How do I come about that? Okay, let's take the minus over there. Okay, then we will get, well, it's all multiplied together, so I could add the exponents because I have same bases, right? Base is x, so I could do n minus 1 plus minus 2n times x2. Because it's the exponent outside, we have to multiply by 3, multiply both of them together. And at the end, we get this. n minus 1 plus minus 2n plus 3 times 3 plus n. And putting them together, we get x n minus 1 minus 2n plus 9 plus 3n. Put them together, what do we get? Minus n and 2n. And 9 and minus 1, we get 8. So here's how we put them together. All right, that's good enough for random cases, but how do we set up somewhat different form? If I have something like this, 2 to k plus 1 power, a2 minus k squared plus 1 divided by 2 to 4k. Let's say we just make that up, right? Okay, then let me just give more flavor here. 4. Okay, how do I put them together into one exponent form? It's all coming about changing all these numbers into power of 2. Okay, This is power of 2. That can be turned into power of 2 by writing